All right. What does an old guy from the 18th century and this method of torture have in common? That's right, it's the Bernoulli equation. Specifically, the dynamic pressure of the Bernoulli equation. The first step of many convoluted steps that you have to take to get your wind pressure, if you follow ASCE 7, is to calculate what's called the wind velocity pressure. First, it has you calculate your KD, and then your KZT, and finally your K sub E factors. These factors are influenced by your structure type, locations, and elevation, and they in turn influence your velocity pressure from step 5 over here. The equation itself includes all those crazy K factors, but it also has this crazy constant out in the front, 0.00256. And also a mysterious square term on the velocity. Now, you fluid dynamic fans may already know where this is going, but I certainly didn't when I first saw this equation. Actually, I'm not going to lie, I generally just accepted this equation without questioning things, but I got curious last time I looked at this, so I thought I'd look in the commentary in the back of ASCE 7. As it turns out, the entire equation is a ripoff of the Jacob Bernoulli, no, sorry, not that one, Johann Bernoulli, nope, not that one, Daniel Bernoulli. His equation says that the total mechanical energy in a steady flow of incompressible fluid remains constant along a streamline. The equation is represented as a continuity, so x plus x plus x is equal to some constant. The pressure component of the relationship related to the velocity is the second one as shown here. Isolating that velocity pressure, we have rho divided by 2 times v squared. We're dealing with air, right? So the density of air is 0.0765 pound mass per foot cubed. Converting that to pound seconds squared per feet to the fourth, of course, is 0.002378, as we all know. If we divide that by 2, like we show up in the equation up top, we get 0.001189. Finally, we need to convert what's given to us, the velocity in miles per hour, into feet per second. So to do that once, you multiply by 1.466. And if you want to do that squared, multiply by that twice and you get 2.15. If you put all that together, rho divided by 2 times that factor 2.15, we get 0.00256. Now we can see here that the only real thing that ASCE 7 introduces is the K values. Everything else is just Bernoulli physics. That's all the engineering I have for you. If you've made it this far, that means you're my biggest fan. Here's some things you could do with your new role as my #1 fan. You could give back to the community through teaching or volunteer engineering work. You could study with me to take the SE exam. Or you could start a cult in my name. Whatever you do, I fully support it. Like and subscribe for more. Okay, bye!